All right, so let's start with a quick introduction myself. So my name is Neha Ojha, and I'm the tech lead for the RADOS team. Been a tech lead for a few years now. Today I'm going to be giving an update, a RADOS update about Pacific and what's coming up in Quincy. So initially we'll start with what has already been released in Pacific a few months back, and then we'll move on to what's exciting and what's new in Pacific. And I've tried to structure the presentation around these four basic themes, which is usability, performance, quality, and ecosystem. Essentially, there will be some features that will cross boundaries, but I've tried my best to categorize them in the most meaningful way. So let's begin with usability features that have been added in Pacific. So the first thing we have here is the upmap balancer is on by default. So I'm pretty sure everybody's aware that we have this balancer module. It's a manager module, which is responsible for balancing PGs across OSDs. Earlier versions did not have this on by default, which made it like a manual step for users to enable this. But with Pacific, we have this on by default, and I think we have confidence that it's pretty stable, so we made this decision. So hopefully users can benefit from this. Then we have this new health warning, which essentially does the job of detecting different daemon versions and alerting the user that they have different daemon versions running in their cluster. So there is this associated health alert that you will see in the Ceph health section. Now, we do understand that this is sometimes expected when you're doing an upgrade or you intentionally had to upgrade some daemon. So you can always use this muting feature that we have to mute this health warning. But in general, this is just an additional guardrail that we've added so that users unintentionally or unintentionally don't forget and leave their cluster in a limbo state after partially upgrading the cluster. So that's that about the health warning. Then there's this ability to cancel ongoing scrubs. So I would like to highlight that when we say ongoing scrubs, these are scheduled scrubs. So Ceph has these scheduled scrubs that run at some configured interval. And for reasons like, when you have some maintenance going on or you have some scenario that you hadn't predicted earlier, you may want to cancel scrubs in order to prioritize something else. Earlier, you did not have the ability to do that, but currently you have the ability to cancel any ongoing scheduled scrubs that are going on in the system. Moving on, we've got, so this is an improvement to the progress module, the way recovery progress is shown in Ceph status. Earlier, we had separate recovery progress shown for different PGs. Now we have like a consolidated recovery progress that is now shown as a part of Ceph status, and you can always use Ceph progress to see more details. The next one is something that is completely new, and I'm excited to talk about this. This is work in progress, of course, but this is a framework for distributed tracing in the OSD by means of a tool called Jaeger. So the idea is to be able to add trace points in the OSD IO path, which can later be collected for performance analysis or even identifying bottlenecks in the IO path in the OSD. And the good thing about this is that there is a Jaeger web UI, which allows you to easily view these reports. So this is, again, work in progress, but hopefully this will make debugging way easier for everybody using Ceph. All right, so moving on, moving to quality. Yeah, I like to name this robustness because, we always have quality issues, but I think we want to make the system more robust in order to not have quality issues. So the first thing we have here, and I also want to note that this is something we've also backported, which is improved PG deletion performance. So earlier it was noted by a lot of users that PG deletion performance wasn't up to the mark. And we did realize that, and we fixed this issue. And we also had some recent comparisons that we did of PG deletion performance before and after this optimization was done. And we found out that we've improved 4x in terms of just simple plain deletion, PG deletion performance. So this is a pretty exciting news in general. Beyond that, in the monitors also, we've consolidated the OSD map trimming behavior. So essentially only use relevant OSD map versions from OSDs that we care about, and not having to hold on to extra OSD maps is the whole idea. So this is also something, this is a stability feature, and has been backported to several versions. Next, I want to talk about Messenger 2.1, which is essentially the new wire format for Messenger 2, both for CRC and secure modes. This comes with a whole bunch of security fixes as well. So this is going to be the new default Messenger version. Moving on, there are, again, some efficiency improvements in the manager module. This is, again, something that we've gotten some reports around and we've fixed it. The first one is about the progress module. So it turned out that the progress module being always on had some issues at scale. And at that point, it was really hard for users to get around it because there was no ability to turn it off. So what we've done here is that we've added the ability to turn the progress module off. Not that we would recommend it, or not that we say that we would, you would need to do it, but for whatever reason, if things just, decide to go wild, you should be able to do that in future. Again, this is useful for and relevant for older releases, so we've backported it. And the next topic here is about efficient use of large C++ structures. This is not just relevant to the progress module, but a lot of other manager modules. Essentially, all the manager modules end up using a dump of basic OSD stats and PG stats and all that kind of stuff. And we found that there was a lot of redundancy, and we also found that there was a lot of extra information that we ended up dumping even when we did not need it. So we ended up doing a thorough search into what is being needed versus what is being dumped to make this handling of these C++ structures easier in the code base. In future, we are also planning to see how we can actually share some of these data structures and even cache some of them to some extent, because some of these modules don't really need to be updated, periodically. So we can afford to cache some information and use it, consume, like separate manager modules can consume it versus individually trying to dump all this information. So we think that these are like stability improvements that are going to be really helpful in terms of the manager. Next, there is this improvement in the Ceph device LS output. Now we also have SSD wear levels that are displayed in this output so that you can monitor it at a regular basis. Moving on, I think this one I'm going to probably skim through because a lot of it was already covered by Josh in the earlier talk. So here, we have a public telemetry dashboard that everybody can view. You just need probably GitHub OAuth authentication to just, be able to use it, which is essentially if you have a GitHub account, you should be able to use it. In terms of RADOS perspective, I'm probably going to talk about more stuff that we are trying to do to be able to make telemetry more useful in the later slides. So I'm going to just move to the next one. Okay, moving on to performance. I'm sure a lot of you are excited to know what we are doing in terms of performance. The first thing I want to talk about under BLUESTORE is RocksDB sharding. So here, essentially the idea is that before Pacific, everything, all the key value data that went into RocksDB was under a common column family. That's a concept in RocksDB. I don't want to go into further details into that, but yeah, just worth mentioning that we will probably share these slides later on, and I've tried to add links to relevant documentation that you can go visit to understand in more detail about what these features are talking about. But in terms of RocksDB sharding, the idea is that in Pacific, we have separate column families to be able to manage data of common types separately. And also that helps with compaction in terms of doing smaller compactions versus doing like a big compaction of everything that's there in the default column family. And hence that also reduces disk space requirements. So it's worth mentioning that RocksDB sharding is enabled by default in Pacific, but anybody upgrading will have to go through a manual step of enabling this in their upgraded cluster. Next, we've got hybrid allocator. This is also something which is widely being used and has also been backported because of all its goodness. It has lower memory use and disk fragmentation and performs much better than bitmap allocator and our legacy stupid allocator. Other than that, we've got 4K min alloc size for SSDs. So yeah, we made this change for SSDs earlier on, but with hybrid allocator, we could also take this decision to make 4K min alloc size for hard disks. So this essentially provides much better, lower space utilization for smaller objects, and it will clearly be visible to users. And the last couple of topics here is about efficient caching. So we've done a bunch of work in terms of making caching more efficient and also tracking memory in finer grained details. So we have this concept of mempools. So we have tried to make sure that all the memory being used is assigned to proper mempools so that users are able to view. So there's a simple dump mempools command that users can use to see where memory is being used. So if there is a bug or some issue where one mempool ends up using much more than required, then we know which areas to attack and go debug further. So that's all for the BLUESTORE stuff in Pacific. And next, I'm really excited to announce that we have quality of service in the OSD in Pacific. It is not on by default, so the behavior is not going to be enabled by default. But the idea is that QoS will be provided by means of a scheduler which is called mclock scheduler. So essentially, before this, we had a WP queue, which was the weighted priority queue, which we were using to prioritize client I/O versus background activities. But now this will be done under the hood by an mclock scheduler. And you can go read about what this does, but it essentially makes everything work under the hood. And the way we have implemented it is we have these different profiles that users can choose to prioritize client I/O versus recovery and other background tasks in the OSD. Now, the reason we have these profiles is that under the hood, the mclock scheduler has a bunch of configuration options, and they also are dependent on Ceph config options. So we don't want users to go through the trouble of trying to understand what those options mean or even have to tune them. So we have these config sets that are implemented under the hood to hide the complexity of tuning mclock parameters and other Ceph parameters. So it should be as easy as just choosing a profile and saying, I want my client I/O to be prioritized at this time, and it'll just do everything under the hood. And yeah, like for Pacific, what we've done is all these Ceph parameters have been optimized for best performance on SSD based off of our extensive testing that we've done in our lab. But in future, we are going to be extending it to hard disks as well. Now, a quick update on what's there in Crimson in Pacific. So for anybody who's not aware of what Crimson is, it's a high-performance rewrite of the OSD. In Crimson, we have implementation of recovery and backfill. We've also added a scrub state machine. It's common to both the classic OSD and the Crimson OSD, and it has been added to lay ground for scrub implementation in the Crimson OSD. It's similar to the peering state concept that we introduced earlier. It's a scrub state machine that has been added in Pacific. In terms of backing store, so C-store is going to be the backing store for Crimson eventually, and the initial prototype of C-store that is in place targets both ZNS devices and traditional SSDs. We've got an initial implementation of O-node trees, OMAP and LBA mappings for Pacific. So the implementation that we have in Pacific will essentially let you run simple RBD workloads. Not too fancy stuff, but in general, you should be able to start up a cluster and run simple FIO RBD workloads on it. And we do have compatibility layer with BLUESTORE. So the way it has been implemented is in form of an alien store. So this is just to make sure that you can start running Crimson in testing and even in production clusters earlier than C-store can come into full shape, and also to provide a migration path to existing users. Moving on, a bit of an update on ecosystem. So we have stretch cluster support in Pacific, and this is also not enabled by default, but users can choose to use this feature. The idea is to be able to configure a stretch cluster across data centers with an arbiter, a third location monitor, which can break ties in cases if there is a network partition or something of a similar sort. Now there are policies around this that you need to follow to be able to configure this kind of cluster. I'm not going to go into too much details, but there is again a link that you can go read later on. Now moving on to Quincy. What's coming in Quincy? In terms of usability, I am really excited to announce that mClock scheduler is going to be the default. And some of you must be wondering that why am I talking about mClock scheduler and usability? Just because this eliminates the need to set thousands of throttles that we have currently in the OSD to make sure that client I/O is prioritized over background ops and vice versa whenever needed. So you don't have to set any of those, and the mClock scheduler will do the prioritizing all by itself. And there is also an automatic benchmarking step which will be performed and this is also all on the OSD startup, and nothing has to be done by the user. So this benchmark is going to be run on OSD startup, and it essentially goes and sets a bunch of parameters that are needed by mClock to make more informed decisions. In terms of the autoscaler, there is going to be a new profile in Quincy. So like the default behavior we have is a scale up behavior, which when there is need for more PGs, we go and expand that. But there is this other profile, which is called the scale down profile, which is going to be default in new clusters. This is essentially for better performance out of the box. This is implemented in the form of a back pressure mechanism that every pool start out with a large number of PGs. And when there is unequal usage across pools, then we increase the number of PGs on the one that needs more and reduce it on the one that does not. So this is, again, something new that is going to be coming up in the PG autoscaler world. In terms of the balancer, will now, so inherently the upmap based balancer just like it does a balancing just by the number of PGs per OSD, but sometimes this is not efficient because you may have a scenario where your OSDs are unequally sized, and in other cases as well, where you might want to actually balance based on the actual OSD utilization versus just the number of PGs. So now we are planning to change this algorithm and also take into account OSD utilization. And finally, display degree of degradedness. So here the idea is to give more meaningful information about how degraded the Ceph cluster is versus just what we do currently. We have a percentage degraded objects that we display in Ceph Health. Here the idea is to be able to let you know how bad some PGs are versus others. Like in some, you can think of an example where if you lose one copy, the PG may become inaccessible after that point. So those will be higher priority in terms of, getting your degradedness fixed versus some where you can afford to lose fewer copies and you can still keep the PGs active and keep writing to it. So those kind of details are what we plan to add further in terms of Ceph Health improvement. Moving on, in terms of quality, more improvements in the monitor. So the monitor is going to be dynamically going to adjust the trimming rate. So currently we have this hard value that we have set in the monitors. So in cases when there is the ingest rate in the monitors becomes much higher than the trimming rate, there can be cases where the monitor just gets backlogged and stops running completely. So in those scenarios, we have made that config option change dynamically to adjust the trimming rate when the ingest rate is higher. This is also something which we think is relevant to older versions, so we will be backporting it. There are further improvements to PG deletion performance in terms of using range deletes wherever possible, or to make the PG deletion code more efficient in terms of RocksDB as well. But that's all. There's an outstanding PR where we are discussing all these kind of improvements. More improvements in terms of manager scalability. So there is this manager stats period. So like I mentioned earlier, that all the manager modules use stats from the OSDs and other places. Now there is this hard value that we have, that the frequency, which decides the frequency at which we are capturing. The manager is capturing all this kind of stats. But what we plan to do is similar to the monitors doing dynamic trimming adjustment. This will auto-tune the stats at which auto-tune the period at which the stats are collected from the OSDs, just to make sure that the managers don't become too clogged with just getting stats from the OSDs. Beyond that, there are other scalability improvements from the progress module and the insights module. Both of them have had issues in the past with scale and trying to handle too much data. So we are trying to do similar stuff for progress module, where we are going to add a configurable interval at which PG map updates will be captured. And even for the insights module, there's a lot of data that we currently persist that we are going to probably stop persisting in the monitor DB completely, or even use a common .manager pool that got introduced in Quincy for these purposes. There are further improvements to slow up logging. So currently we log everything in the cluster logs, and it also gets goes through Paxos and gets persisted in the monitor store. So we want to eliminate all that complexity and just simply have a configurable number of slow ups that we capture and add it to the manager log. So the OSDs are going to report those slow ups to the manager, because for debugging purposes, all we care about is what kind of slow ups are showing up and when they start coming up. So I think that is an efficiency improvement that is going to be really helpful for larger clusters. The other thing we have is we also want to make the whole log monitor code more efficient. So that's also something we'll be working on in Quincy. In terms of performance, quality of service is going to be expanded. As I said, we are going to be doing more optimizations for HGDs. We are going to also include background activities like scrubbing and PG deletion for prioritization purposes. The default profile that we'll be using in Quincy is going to prioritize client I/O, but users can always go and configure their cluster to use a different profile. Like you can use the high recovery ops profile, which will prioritize recovery over client I/O. And finally, the next big piece here is client versus client. So all this earlier stuff that I talked about was essentially client I/O versus background stuff in the OSD. This is going to be QoS in terms of different clients, not the OSDs. But this, again, is work in progress. Now, coming to BLUESTORE, the one big change that is coming up is removing allocation metadata from RocksDB. So we've realized that with RocksDB sharding, this is possible. So what the idea is to be able to remove this separate column family that stores allocation metadata in the RocksDB when we are doing every write. And we rebuild the allocation map. So essentially, this is only needed in cases when there is a failure. So the idea is to be able to rebuild this allocation map in failure scenarios. And what this gives us is significant small write performance improvement. So you are saving on every write that you're doing to the cluster. So I think this is, again, a huge improvement coming up in Quincy. There are other improvements to split cache. This is more in terms of simplifying the code, bug-free. I mean, we realized some recent bugs around locking in this area, and we want to ensure that we don't have such issues in future, and also simplify the code to make it more manageable. So that's the split cache idea here. And we also want to revisit cache age bin. This is something we've been working on earlier, but we gave it a halt because we wanted to get RocksDB sharding in first. So this is going to be built on top of RocksDB sharding, and we just age the cache based on age. That's essentially what the name means, and that's what we are trying to see if it still is relevant or not after RocksDB sharding. And finally, this is more probably a developer-friendly thing, or maybe a user-friendly as well. So we have added a simple benchmark, which is called OMAP bench, to benchmark OMAP-heavy workloads. Earlier, this was a challenge. We had to go through RGW workloads or even cost bench and the setup that all these benchmarks require to do simple benchmarking. So this is going to be a simple tool that people can run, or users can run, or devs can run to benchmark OMAP performance and also identify any performance regressions. Finally, in terms of telemetry, as Josh mentioned earlier, we plan to add a performance channel in telemetry. So the idea is to be able to capture useful metrics like OSD perf counters, etc., from telemetry from user clusters, so that we have more meaningful data points to profile our workloads on. And we as devs would like to use this data to adapt our existing guidelines as well. Like some of the guidelines that we make about how much your wall partition should be or DB partition should be are based off of our analysis and some of our conservative ideas as well. But we want to get more realistic information from real users, and having the knowledge of what kind of workloads they are running, we might be able to make more informed decisions in terms of recommendations. And that's the reason I say it's definitely worth opting in for. And the next thing is about enabled manager modules. So in every release, we have some always on and modules that are not always on, but you can enable them. So we want to be able to gather information about which manager modules are actually being used in user clusters, and to be able to improve those or prioritize those more than the others. In terms of Crimson, we are going to be adding Scrub implementation in Quincy, and there's going to be support for snapshots. That's the last piece. When I mentioned we were able to run simple RBD workloads, if we have this snapshot piece, we will have full support for RBD workloads in Crimson. We're also going to be working on multi-core support. So currently it's one-to-one core to OSD mapping. So we are planning to extend this to multi-core support. And in terms of CStore, the main focus is going to be make it feature complete so as to start initial tautology testing. We've already started Crimson tautology testing and are extending the Crimson RADOS suite, as we speak. But the idea is to also be able to test CStore in tautology. There's also going to be some initial performance work in this area, and we are also going to be working on random block manager and support for persistent memory support. So the ability to run on all kinds of devices is next step here for Crimson. And finally, in terms of ecosystem, we have already merged the ability to auto-generate documentation from Ceph config options. So there is no need essentially of duplicating the work of adding stuff to options.cc and a separate RST file. So anytime you add anytime you add a config option, it goes in with documentation and docs get generated automatically. And finally, Redmine integration with Tracker, which I think Josh already spoke about, so I'm going to skip that. But the idea is to also make some of our asserts and stuff in the OSD more unique to be able to help telemetry reports be clustered in the right possible way. So that's all I had. I want to open it up for questions now, if there is time. Okay, I think.
So we have a couple of questions. First one is, can QoS eventually be adapted to prioritize client I/O in different pools? As an example of having a high priority pool A and a low priority pool B.
Yeah, I think that's the piece about client versus client. I can see that we can extend that to a pool as well. So essentially a pool could have a profile enabled, which would let that pool be prioritized over other pools.
And the second question I have, but it was written out specifically for RBD, maybe for RADOS, but what fancy I'm guessing RADOS stuff can't be run or ran with CStore?
At the moment, as I said, CStore, there's basic ability you can start up a vstart cluster and start running a simple RBD workload. Snapshots are still not there. But with Quincy, I'm hoping that we will be able to also support snapshots even without CStore, maybe, if not with CStore. But you should be able to have snapshots in Quincy, and later you can have snapshots and CStore, both.
CStore for Pacific isn't capable of running an OSD yet. It has basic unit testing, but that's it. Quincy is when you should be able to start up an OSD and run an RBD workload.
Okay. Are there any other questions for Neha, specifically for this with this RADOS update? Okay. All right. Well, thank you, Neha, for the update. And we're now going to go ahead and start on Ceph on Windows with Alessandro.